Welcome to this podcast tutorial on pachyderm acoustics for rhinoceros. In this particular podcast tutorial, we will look at how to visualize some of the acoustics in the model based upon the previous podcasts where we have looked at the setup of materials, simulation setup, sources, receivers, and so forth. And this podcast we will focus only on the animation of particles as a way to visualize the spreading of sound in the space. So what we will do is that we will again go to the pachyderm acoustics, in this case we have the hybrid models, or the basic interface open, but with the one we are interested in this podcast is the particle animation. So when you click this one, you will see a relatively simple interface in which you can set up the conditions for making that particle simulation. You can choose between 3 different types of visualization types. Typically I will leave it at smart particle wave. The number of rays that you want to cast and have the particles based on, let's say in this case we put 10,000. The cutoff time, how long do you want the particle simulation to run, animation to run. In this case we just leave it at 300 milliseconds. And again some environmental conditions, the air temperature, how long are we running it, and what frame rate are we running it. Then basically we are ready. I could just press preview and we should be able to see particles flow around inside our space based upon these settings. But what we want to perhaps do first is to check whether this interpolation from the max to the minimum makes sense. In this case we are looking at the sound pressure level, which we know from our source is around 65 SPL, which means that in the event that we will press preview now, it will be all the particles be red, because basically we have a wrong interpolation set. So if we start, let's say by 60 instead, and let it run downward, then we will basically go with that. So let's try and see what it says here. Press preview, and it starts to find the rays of the model that has been computed, and then we have an animation running, and perhaps it's we see it here in the right viewport, where we will be able to see the spreading of the sound. Obviously this happens in 3 dimensions, not only in 2D, but for now perhaps it's easiest to see in this particular geometry how it spreads. Let's just see the current time. It's at 80 and we set it to run to 300, so it will be a little bit before it restarts. But here we should be able to see then that the energy slowly goes out of the sound out of the particles as they're moved around and bounces on surfaces that absorbs the energy. And we can see that the predominant amount of energy is now down to the sound pressure level is down to 30 after 0.2 seconds. And we have a full cover of the space, at least in this 2-dimensional view. So we will just run to the end, and then it will restart automatically, to where I'll just make another comment on what could be interesting to look at here. So we'll see it run. So what you can do in the process is also you can stop it at a particular, and you can basically go by frame by frame. So when you come to the end, it will basically restart, and you can see very controlled in this sense how this sound is spread from your source in the space and how it bounces off. So here we have, of course, the wavefront from the source and the first reflections that have already been bounced off the floor. And we start to have reflections coming back from the audience and the back wall, whereas the wavefront is still not fully filled the space in the top of it. And now we start to have the wavefront that is bounced off the big convex roof down towards the speaker and the audience. So in this way you can start to get a grasp about how is sound spread in the space. Are there, for instance, pockets that create sound shadows and so forth? So rather than looking at it in terms of how many a quantitative aspect only, it also gives a kind of a qualitative assessment of the spreading of sound in your space. So this was a relatively fast tutorial podcast on how to apply particle animation as a way to visualize the sound phenomena, the sound properties of a given space in your model. Thank you for watching.